Okay, welcome to the class. Today class on question number 16. What is the question number 16 says? Let us let us see question what they thought. On hydrolysis of a compound, two compounds are obtained, one of which on treatment with sodium nitrite and hydrochloric acid gives a product which does not respond to iodoform test. The second one reduces Tollens reagent and Fehling reagent. The compound is. Okay, the compound is. This is the question. On hydrolysis of the compound, two compounds are formed. Which one of the treatment with sodium nitrite and hydrochloric acid gives a product which does not respond to iodoform test? Okay. One of which on treatment with sodium nitrite and hydrochloric acid gives a product which does not respond to iodoform test. This is the first point. Hydrochloric acid gives a product which does not respond to iodoform test. The second reduces Tollens and Fehling. The compound is. Let us take an example for that. First of all, take an example A, okay, option A, then write suitable answer for it. Option A, what they given is CH3, CH2, CH2, NC. NC, the compound hydrolysis of this compound. Hydrolysis of this compound. Okay, let us hydrolyze this one. On hydrolysis, isocyanide is hydrolysis on hydrolysis. On hydrolysis, this is get converted into amine and carboxylic acid. Okay, we know on hydrolysis of isocyanide, you can get amine plus this is get converted into amine and this is get converted into carboxylic acid, HCOH. This is converted into carboxylic acid. Next question. This is two compounds are formed and hydrolysis of this compound. Next, this was react with Tollens and Fehling reagent. Tollens and Fehling reagent. Okay, we know. Whereas this one react with NaNO2 plus HCl gives rise to CH3, CH2, N2 plus Cl minus, which is unstable. So it is easily get converted into CH3, CH2, CH2OH. Okay, converted into alcohol. This is not react with iodoform, not react with I2 plus NaOH, not react with this one. This is not react with iodoform. I2, this is not react with iodoform. Okay, not react. So I think this is the correct answer for the question they have given here. Question number 16 is concerned. On hydrolysis, the two compounds are obtained, one of which treatment with sodium nitrate and hydrochloric acid gives a product, means alcohol we got, which does not respond to iodoform test, we know. The second reduce tolerance and failing. This is the compound A. Okay. If you feel the second one is correct one, then you can get on hydrolysis of this one. Hydrolysis. What happens on hydrolysis of this one? CH3, CH2, CH2, COH and COH. This is get converted into COH plus ammonia. So you may not expect anyone. Okay, this is not react with, then this is not react with sodium nitrate and hydrochloric acid. So the concept is wrong for this one, and it is not react with tolerance and failing. So that is this is also, these two are literally no meaning for the corresponding these tests. Okay, so this is the correct one for the uh, answer is concerned. Next, let us focus question number 17, what they said. Some reactions of amines are given, which one is not correct. Okay, which one is not correct? Let us focus question A. Question A, what we understand from this question number A. Okay, they have given secondary amine on reaction with NaNO2 plus HCl. What we got? Okay, let us see the answer. Here they have given secondary amine NCH3 twice on reaction with NaNO2 plus HCl. Okay, these two get reacted and they can create nitroso-cation, NO plus cation. This cation on electrophilic substitution reaction is get substituted, this electrophile get substituted here, then you can get the expected product is like this. Expected product is like this. Okay, NO and double bond O you can expect. But the answer which they given or which the answer we got is different one. Okay, we can expect like that, but here this one is not correct one. So they ask us which is not correct. This is not correct. So this is the one option. So remaining things you may observe what happens. Amines on reaction with HNO2. So this is you can get diogenium. Diogeniums are aliphatic diogeniums are unstable that converted into alcohol. So this is correct one. Okay, this is correct one. What they asking is incorrect. This is incorrect. So this is correct one, and this is also correct one. Okay, this is easily HCl is elimination, then remaining product is like this. This is also gives NO plus. NO plus is get reacted here, then you can get this one. So incorrect product is A. A is the incorrect product. Next, let us focus question number 18. Okay, question number 18, what they ask us. The organic compound C3H9N let us treat A, when treated with nitrous acid, gave an alcohol and N2 gas was evolved. A, on warming with chloroform and caustic potash gives C, which on reduced isopropyl give isopropyl methylamine, predict the product A. Okay, let us see the answer, which one is the correct one. Okay, which one is the correct one for this question. Okay, let us focus. Let us take an organic compound C3H9N. Okay, C3H9N. Let us treat it as A. On treatment with nitrous acid HNO2 gave alcohol. Okay, alcohol plus N2. Alcohol plus N2. It means it has primary amine. This is primary amine we got from this reaction. You get the information that this is A is primary amine. Okay, next point. Evolve. Next one. On reaction with chloroform CHCl3 plus caustic soda NaOH. Okay, NaOH. Okay, chloroform and NaOH gives C. Okay, this is can gives isocyanide. Okay, this is gives isocyanide. Okay, give C. C is this one. Okay, which on reduction give isopropyl methylamine. This which on reduction gives isopropyl methylamine. Okay, isopropyl which is on reduction, you can get isopropyl methylamine. Okay, you can get isopropyl methylamine. Means let us take A is option A. Then you can write what happens. Okay, CH3. Okay, it is. It is A, option A. Okay, it is right option A here. CH3 CH3 NH2. Okay, NH2. Okay, NH2 on reaction HNO2 you can get CH3 CH3 OH. Next, what happens with on reaction with chloroform and NaOH? You can get isocyanide CH3 CH3 and C. On reduction you can get CH3 CH3 NHCH3. Okay, here this is known as isopropyl methylamine. This is known as isopropyl methylamine. Okay, so let us focus the answer. Isopropyl methylamine we got isopropyl methylamine. If option A is this one, then you can get this type of product. So what we say is answer is A. Okay, this only gives reduction product isopropyl methylamine. Okay, next let us focus question number 19. 19. What is the product obtained in the following reaction? Zinc in presence of any ammonium chloride, you can get the product is this one. Option A is the correct one. This is the easy to remember. Hydroxylamine, NHOH. Okay. Next one. Which of the following compound most basic? We can easily say this is electron withdrawing group. This is less basic. This is then compared to this one. CH3 increases the electrons. So this is also electron withdrawing group. CO is electron withdrawing group. So it can electron releasing group. Then compared to these four, this is the most basic one. How can we say this is the most basic one? Here CH2 is attached with the NH2. Here is the only compound NH2 attached with the CH2. CH2 is electron releasing group. Releasing group. Okay, which is not possible in any other structure. So this is B is the most basic among the following given compounds. Next, aniline sets the following reaction is colored compound Y. Colored compound Y. Okay, let us write the colored compound Y. And this is very easy. Okay, we already remember that one. We know from the previous point of view. Okay, let us write here and then okay, let us write what happens. Okay, let us focus. Aniline on reaction with this is one NaNO2 plus HCl. NaNO2 plus HCl can give benzene diazonium salt N2 plus Cl minus, which on reaction with NN dimethylamine CH3 twice. So this on reaction with this one, this is known as coupling reaction in acidic medium. In acidic medium, you can get coupling product is we know from the textbook. This is also from the textbook and double bond N. Okay, N CH3 twice. So this is the A is the correct compound. You can get it. Okay, this is the previous bit. Okay, only one thing we have to remember: NN dimethylaniline. This is known as NN dimethylaniline. N comma N dimethylaniline. This is NN dimethylaniline. So you can easily got the answer. Okay, next one 22. Let us focus. Question number 22. What they said. Which of the following statements about primary amines is false? Primary amines is false. Alkyl amines are stronger base than aryl amine. We know alkyl amines are stronger bases than aryl amine. Next one. Focus. Alkyl amines react with nitrous acid, produce alcohols. This is also correct one. Aryl amines react with nitrous acid to produce phenols. This is the incorrect one. Aryl amines are stable. Let us compare aryl amine and alkyl amine. Alkyl amines means CH3 CH3 NH2 on reaction with HNO2, you can get alcohol. Whereas aryl 1, okay, you can aryl amine on reaction with HNO2, you can get diogenium salt N2 plus Cl minus N2 plus Cl minus. Okay, this is the only product you can get it. Okay, you cannot get any other product. This is HNO2 on reaction with not get converted into the phenol. This is not get converted into OH. This is wrong one. Okay, because it is stable. Okay, there is a reason why aryl amines react with nitrous acid, produce phenols is the wrong one. Next, let us start question number 23. Question number 23. What they said is this is secondary amine. Okay, secondary amine. Secondary amine on reaction with NaNO2 and HCl gives what is the product. Okay, how to solve this problem? Let us focus. Let us focus the solution for this one. Okay, secondary amine, you write down here the secondary amine NH CH3 NH CH3 plus NaNO2 and HCl. These two on reaction can generate HNO2. HNO2, what is the structure of HNO2? Means HON double bond O. Okay, HNO2 in presence of acidic medium, it can give H plus. Okay, these two on reaction gives HNO2 plus NaCl also. And in presence of acidic medium, which is react on OH plus, then it has lone pair, then H plus is attached to this one, and they can get separated out because their reaction is like this HO2 plus N double bond O, then it is replaced like this, then you can get N plus double bond O. Okay, this is the cation. This is the cation you can get, and this one is reacted here like this. This is, you can write like this, NHCH3, and it has lone pair of electrons. Then this is approaches to here, then what happens? See, like this. This is on nitrogen H is formed and CH3. There is donation of electrons from this one to this one. Okay, this one to this one. This lone pair of electron, this goes to donated to N plus. Then you can get N double bond O, and it was getting the plus charge because it can lose these electrons. Okay, then you can get like this. Then simultaneously it can H plus is removed from here. H plus is removed and lone pair of electrons are restored here. Then you can get like this. The compound is Kn CH3 after removal of H plus removal, you can get lone pair of electrons, and nitrogen you can get the lone pair of electrons. This is the compound you can get. Okay, let us see which is the correct answer. So this is the correct answer from this one. Okay, let us focus on 24th question. What is the question? Nitrobenzene can be prepared from the benzene by using mixture of HNO3 and concentrated H2SO4. The mixture nitric acid act as? This is very important question. Let us focus how to solve this type of question. Question number 24. Okay, let us focus question number 24 in. Oh, okay, let us start the question. Predict the product secondary amine. This is the secondary amine on reaction with NaNO2 and ACl. What is the product? Okay, how to solve this type of questions? Let us see the answer. Let us see the answer and explain. In secondary amine, we have taken secondary amine here, secondary amine on reaction with NaNO2 and ACl. You can get HNO2 and NaCl initially. Then you can write HNO2 is like this. HNO2, you can write HNO2 is like this. HO, N double bond O. In presence of H plus, this is get converted into like this, and after removal of water, you can get the cation like this, NO plus. Okay, this NO plus on reaction with secondary amine, you can get this N nitrogen N plus, donate the electron pair for N plus, then you can get plus, here nitrogen get the plus charge. Okay, next what happens? See here, let us see what happens. Okay, let us rub it. Okay, there is some clarity is missing here, so resolve this one. Okay, after writing this NO plus, okay, this can donate electrons, so on donation nitrogen get positive charge, and then if H plus is removed, then it can get the electrons and then get neutralized, and then you get the product like this. So what is the answer here? The answer is D. Okay, see, the answer is D. Next, what is the answer for question number 24? How to answer question number 24? Nitrobenzene can be prepared from benzene by using mixture of HNO3 and H2S4 in the mixer. Nitric acid act as. The question is, in this mixer, nitric acid act as. Okay, let us focus question number 24. Question number 24. On nitration of benzene. Let us see question again. Nitrobenzene can be prepared from benzene. Okay, correct one. Okay, benzene on reaction with concentrated HNO3 plus concentrated H2SO4. Okay, both of them can react. HNO3, like you can write like this, H2SO4. Okay, H2SO4 you may write like this, and then here on reaction H2SO4 is converted into H plus and HSO4 minus, and then this H plus get attached to this one. You can observe H2 plus N double bond O NO. After removal of this one, you can get NO2 plus H2. So H plus are donated by the H2S4 and OH is donated by HNO3. So in this case, HNO3 is known as base. Okay, H2SO4 act as acid. So the question is solved here. So question 29, 24, let us focus 24. Okay, mixed nitric acid act as base. Nitric acid act as base, H2S4 act as acid. So question number 25, let us focus on question number 25. Which one of the following on reduction with lithium aluminum hydride yields secondary amine? This is straight away you can say any isocyanide is get reduced to secondary amine. This is fixed one. Iso all isocyanides are get converted into methyl isocyanide. For example, methyl isocyanide on reduction you can get secondary amine. Straight away you may write like that. So, and all secondary amines are coming from the on isocyanide reduction. Okay, this is the way I can get you. Okay.